Okay, hello everyone. I welcome to all in our lecture series on laser physics. In this lecture series, we are discussing these topics, which are most essential for BSc, BTech, MSc, MTech, and various entrance examinations. In our last class, we have been discussed semiconductor diode laser, its construction, working, and applications. With note in detail, we have been discussed. In this class, we are going to discuss carbon dioxide laser, its construction, working, and applications. Okay, so let us start. Here, these are the basic features of carbon dioxide laser. Highly used as continuous laser, in which laser action will be achieved from the vibrational energy of carbon dioxide molecule. It produces laser beam of wavelength around 10.6 micrometer and 9.6 micrometer. This is a 4-level molecular laser system having very less beam divergence, approximately 1 to 10 milliradians. Now we are going to go for the construction part of carbon dioxide laser. This figure represents the construction of carbon dioxide laser. The experimental arrangement of carbon dioxide laser is shown in this figure. It is developed by Indian-born American scientist 𝒂𝒑𝒏 at Bell Laboratory in 1964. In carbon dioxide laser, the active medium is a mixture: carbon dioxide, nitrogen, and helium gases with a proportion of 1:2:3, placed in a quartz discharge tube of length 5 meter and diameter 2.5 centimeter. So this length is your 5 meter, and this one, the diameter of this discharge tube, around 2.5 centimeter, at a pressure of a few of mercury. NaCl windows are placed at the end of the discharge tube. So this is the discharge tube, in which 1:2:3 proportionate mixtures of carbon dioxide, nitrogen, helium gas are present. At the both the end, we can found NaCl windows. Here, this one, NaCl window, and this is NaCl window. Why NaCl window? At the end of the discharge tube, inclined at Brewster's angle to the resonator axis to obtain the plane polarized laser beam. Okay, a pair of concave mirrors used to reduce the diffraction. Here concave mirrors. This one, this concave mirror is fully reflected, and this concave mirrors partially reflected, through which laser beam will pass through or collected. So this is all about the construction part of the carbon dioxide laser. To pumping the mixture of the gas used as electric discharge. That means this is the electrical discharge method to pump the mixture. Okay, that will be produced by DC excitation. Now we are going to go for the working of carbon dioxide laser. Here, 3 type of vibration modes possible in carbon dioxide molecule. Carbon dioxide molecule can vibrate with 3 different independent mode of vibration. The 3 state of vibration of molecule can be represented by 3 quantum numbers m, n, and q. Symmetric stretching mode. First we are going to discuss symmetric stretching mode. The animation here you can see the symmetric stretching. The oxygen molecules stretched along the axis where carbon atom is at rest. Same thing it has been written. In this mode, the oxygen atoms oscillate along the axis of the molecule simultaneously, departing and approaching the carbon atom, where carbon atom is stationary, which is called as your symmetric stretching mode vibration. The corresponding energy states, if I am going to consider 3 dimension, suppose this molecule is in the 3-dimensional space, then the corresponding energy states will be written as mx, x component, y component, z component, m is the quantum number, mx, my, mz plus 3/2 h mu s represents the frequency belongs to symmetric stretching mode. Okay, See, this also can be written as H cross omega S. Omega is the angular frequency. So H cross is nothing but H by 2 pi. Omega is nothing but 2 pi by Ts. 2 pi got cancelled. So H into 1 by Ts is nothing but frequency. No issue. So here I written in the form of H mu. Now we are going to consider bending mode. In this mode, all the three atoms undergo oscillation perpendicular to the axis of the molecule. So this is the axis of the molecule, right? The three atoms undergo oscillation perpendicular to the axis of molecule, where oxygen and carbon will be opposite in the direction motion, where the oxygen and carbon atom will be in the opposite direction motion. Okay, the corresponding energy states are represented nx plus ny plus nz plus 3 by 2 h mu b for bending mode. Here you can see this one. If oxygen move this side, both the oxygen, carbon will be moved this side. This is called as your bending mode. Here you can see this one is your, this is your asymmetric stretching, but this one is your bending mode. Okay, and this one is your asymmetric stretching, what I am going to discuss now. Now third one is your asymmetric stretching mode. In this mode, the three atoms oscillate along the axis. This is the axis. Okay, this is the axis of the carbon dioxide molecule. Along the axis, with both the oxygen atom moving in the same direction, while C atom, carbon atom, will move opposite direction. This one, this motion, here you can see. Wait, this one, this motion is called as your asymmetric stretching mode. This one is your bending mode. Okay, and corresponding energy states represented as Qx, Qy, Qz plus Qi plus Qz plus 3 by 2 h mu a. Mu a represents the frequency belongs to asymmetric mode. Okay, at any instant, the carbon dioxide molecule can be vibrate in a linear combination of these three fundamental modes. Okay, now we are going to go for a reaction mechanism of this carbon dioxide laser system. When current passed through the mixture of the gas due to DC excitation, this is the DC excitation means discharge happens, the nitrogen molecules will be excited by capturing the electron. So here nitrogen molecule captured one electron, and here it is formed as N2 star, means N2 star represents the excited nitrogen molecule. The excited nitrogen molecules interact with the ground state carbon dioxide molecules through inelastic collision and make them to excited to the level E4. So this N2 first excited by capturing the electron to this state. So this is nothing but N2 star. Now N2 star will collide inelastically with carbon dioxide molecule which are in the ground state, and those carbon dioxide molecule will be excited to the E4 state. Here it is written. The N2 molecule return after collision, in the inelastic collision, N2 molecule will be de-excited to its ground state after inelastic collision with the ground state of carbon dioxide. Okay, same thing it has been written. So excited nitrogen molecule will be interacted with carbon dioxide molecule which are at the ground state. The carbon dioxide molecule will be excited to E4. After that, this N2 excited N2 nitrogen molecules will de-excite, will come to the ground state. Okay, this process, if this process will happen for some times, the population inversion will be created between E4 level and the E2, E3 and E2. That means population inversion, after sometimes population inversion will be created between E4, E3, E4 and E2. Between these, population inversion will be created. If a population inversion created, that means we can get the laser action. Now we are going to discuss the various transitions happen in this carbon dioxide laser system. Here you can see E0 represents the ground state of carbon dioxide. This one. E1 energy level due to symmetric stretching of carbon dioxide. This is your E1 state. E2 energy level due to symmetric stretching of carbon dioxide. E1 and E2 both are, E1 and E2 represents the level due to the due to the symmetric stretching of carbon dioxide. E3 represents the bending energy level due to the bending mode vibration of carbon dioxide. E4 represents the energy level due to the asymmetric stretching of carbon dioxide. So here, uh, due to asymmetric stretching of carbon dioxide, the carbon dioxide will excited to the higher energy level. Okay, so for the laser action, the carbon dioxide should in the mode of vibration of asymmetric stretching, right? Right. Now, a set of three quantum numbers here, 0, 1, 0, means that the carbon dioxide molecule is a molecule in this energy state is in a pure symmetric stretching. So here 0, 1, 0, where is the 0, 1, 0? See, 0, 1, 0 represents the purely symmetric stretching. Similarly, explanation can be given for other set of quantum number like 1, 0, 0 and 0, 0, 1. So here if somewhere it is written 0, 0, 1, that means it is represents the asymmetric stretching of carbon dioxide. Okay. Okay. Now here, any of a spontaneously emitted photon the carbon dioxide molecules are excited to the higher energy level E2. Okay, any one of the molecules, carbon dioxide molecules, spontaneously suppose transit to either E3 or E4 spontaneously, one photon particle will be emitted, and that photon particle will interact further other carbon dioxide molecules which are in E4. When it will interact, that time stimulated emission will happen in this system. So this spontaneously emitted photon will be interacted with only stimulate the other carbon dioxide molecules which are at E4 level. Then we got the stimulated emission from E4 to E3 or E4 to E2. If E4 to E3 transition happens, we can get 10.6 micrometer wavelength laser. If from E4 to E2 stimulated transition happens, then we can get 9.6 micrometer wavelength laser. Same thing I have been written over here. Any of spontaneously emitted photons will make the molecules undergo a transition between E4 to E3, thereby generating a stimulated photon. These photons traveling along the resonator axis undergo multiple reflections at the optical resonator. See, one photon here. Suppose one photon spontaneously we found in this cavity. One photon. That one photon, due to this is highly reflective, fully reflecting mirror, this will be reflected from this reflector. Again, will be moved up to this much distance. Again, suppose it is reflected. So with this motion of this photon will interacted with carbon dioxide molecules which are on the E4 state. So when it will interact, that interaction is the stimulation interaction. So when it will stimulate other carbon dioxide molecules which are at E4, then these carbon dioxide molecule will transit to lower state stimulately. Same thing it has been written. So here these photons travel along the resonator axis, undergo multiple reflections at the optical resonator mirrors. As a result, the transition E4 to E3 yields an intense and coherent laser output of wavelength order 10 to the 6 micrometer. Similarly, if the transition between E4 to E2 generates a laser beam of 9.6 micrometer wavelength, we can found both the wavelengths falls in far infrared region. The transition between E3 to E1 here, E3 to E1, this transition particularly, and E2 to E2 to E1 transition, this transition, due to elastic collision between excited carbon dioxide molecule with unexcited carbon dioxide molecule. Okay, finally, the elastic collision between helium atoms, the carbon dioxide molecules makes the transition E1 to E0. E1 to E0. The carbon dioxide molecule move from E1 to E0 by uh, by elastic collision with helium atom. So this transition of carbon dioxide molecule is nothing but interaction with helium molecules. Okay, that is helium. Here helium molecules helps in depopulating the lower level E1. So here helium molecule helps depopulating the carbon dioxide molecules in E1 level. So when the carbon dioxide molecule will come to the E1 level, these carbon dioxide molecule will interact with helium and with faster rate it will de-excite to the ground state. So as much as it will be depopulate, as much as rate it will depopulate, with that much rate it will pump to higher state and the laser action will be continuous. So helium atom only help in depopulating the lower level E1. In addition to this, helium helps to conduct heat away from the wall of the discharge tube. So it also help to maintain the temperature itself, means conduct heat away from the wall discharge tube, which keeps carbon dioxide cold or keep a particular temperature. And this is achieved due to the high thermal conductivity of the helium. Okay, so this is all about your construction, working of the carbon dioxide ledger. So these are the important applications of carbon dioxide ledger. It is widely used in material processing such as drilling, cutting, etching, welding, melting and annealing. Widely used open air communication. It is used for pollution monitoring, remote sensing and LIDAR. It is used in the medical field to perform microsurgery and bloodless surgery. Disadvantage of carbon dioxide ledger is this one. Carbon dioxide molecule of active medium dissociate into carbon monoxide after certain hour of operation, and the carbon monoxide may contaminate the active medium. Thus the carbon monoxide has to be periodically removed away from the vacuum pump. So this is the small disadvantage of carbon dioxide ledger. Otherwise many applications we can found in our day-to-day life. So this is all about your construction, working and application of carbon dioxide ledger. Okay, here I am going to stop this lecture. Thank you so much for watching this video. Next class we are going to discuss examer ledger.